The cannon on our robot isn't my design. In fact, I found this design to be very inspirational, and I've got some ideas for other things I'd like to make based on this idea maybe. But user Canino on Thingiverse has posted the Disc-o-Matic, and you can go online and download that file, and there's a whole number of part files on here, and you can see that they've posted it and put it onto a number of applications. And yeah, the different parts on there, you can download it, and then you can toolpath it, slice everything up so that you've got it put together. Now, if you don't have an Ultimaker or a bed big enough to do this all in one piece, you can do individual parts. You can do different parts with different colored materials. It's kind of up to you, but I've kind of got this sliced to all fit on our Ultimaker. And it's coming together very nicely on there. So anyway, quality 3D printing does make a difference for this project. And so get yourself a nice looking print. Okay, so here we go. You do need a reasonably decent quality printer to get reasonably decent quality prints. I've set this file up to print everything out together on one print, but if you've got a smaller printer, you can of course print individual parts. And you know, you can do it in different colors if you do it in different parts too. Always be careful separating the parts from, usually I use two hands for this, but never push this sharp blade towards your hands. Always use something else to secure those parts. Okay, to make things look a little more interesting, I like to replace this part with a couple of parts in a different color right here, because this is the part of the cannon that's going to be sliding back and forth, and these gears sit right in here. And just makes life look more interesting, and you can swap out the colors of some of your discs. Just find somebody who wants to swap and get your colors from you, or print them separately if you're doing it yourself. Okay, now these two parts are going to fit together, and the elastic band is going to hold them in here, and the gearbox is going to slide this back and forth. So what I like to do is I like to make sure that they slide nice and smoothly, and so I'll hold that down in place, and I'll spend a couple minutes just sliding this back and forth and pushing on here, keeping pressure on it at a few different points. And you'll see that as you do that, you start to wear down the back a little bit and start to smooth off any little ridges on the top that resulted from, you know, any just rough surface finish in your 3D printing process. So I find just doing that gets the first little bit out of the way. It breaks everything in a little bit, and then you can take this part and line up the holes right in here. You can rest that on top, and it should sit in there, and with your hand resting on here, you should be able to slide that back and forth, and it should slide fairly nicely and smoothly. So make sure everything's broken in before you start putting things together, and you'll save yourself a little bit of a hassle. There you can see just a little bit of wear on there from the top. Now, if you're thinking about lubricating it, well, maybe I have tried putting a little bit of graphite in there. Don't put a lot of lubricant in there, whatever you choose to use, because you could end up just having a big mess of lubricant in here. Generally, this should slide fairly nicely once you've got it broken in. Okay, these little gears right here, they were printed in a different orientation. If they'd just been printed this way, then you would have had layers in between the gear teeth. But the designer of this did a really clever job and printed them this way, so the layers run in this direction, and therefore when you flip the teeth up like this, where they're getting the force, they're going to be a lot stronger. So that means that you have to glue these into right here. Now, if you fit them in just like that, it might be a little bit of a hassle. Sometimes I find I have to kind of get in there, and they do fit, but you kind of have to bend, gently force them into place. Now, that's an amazingly beautiful, nice, tight fit. Depending on the quality of your printer, it might not be quite so tight. To make sure they stay in place, we're going to use some cyanoacrylate adhesive. Any fine, thin adhesive should do the trick, and it doesn't take much. Just a couple little dabs right along there. That's probably way more than enough. And so we're going to do that for both sides. And you'll notice I've got plastic drop cloth down on here. Anytime you're working with cyanoacrylate, you want to make sure that you don't get it onto any surfaces that you feel obliged to clean up later on, because it could be a real pain to clean up. And try to keep it off your fingers too. Okay, there we go. That fits in, and check your inside fit right there to make sure that that's nice and snug right inside there, because of course this is going to be sliding back and forth past things. And then flip it around and do the other side. Okay, now in the official instructions it says to glue your motor in here, but I really don't like doing that because well, it's really hard to replace a motor once it's glued in place. So, and sometimes you do want to replace your motor, the gears can strip, but the design does leave us this nice little hole right here. The catch is, if you put a round-headed bolt on there, it's going to interfere with the mechanism. So we want to use a flat-headed screw. I think this is a number 6 machine screw, and it's just about the right size to go right in here, but we have to take a countersink bit and we have to drill this out so that it's countersink. So I'm going to take that over to the drill and countersink it so that this head sits flush on the surface, and then I can drive a couple of screws in, one from each side, and this will be very securely mounted in there. Okay, so countersinking next. Okay, well, you got it out at the machine shop getting all countersunk. You may as well come in here, and at some point in here you got to do this. It doesn't really matter which order you do this in, but I grabbed some 26 gauge wire, and I'm just soldering these little terminals in place, making sure that I don't accidentally solder them to the motor or anything like that. Just a nice little job in there. A little harder to do this while I'm filming too. But anyway, yeah, a couple of nice shiny solder joints right in there. And leave yourself a length of wire that's long enough to reach back through your cannon mount shield and down to your board, and we'll crimp a connector onto the end of it in a little bit. And don't worry about which side's red and which side's black, because we'll figure that out when it comes time to crimp the connector on. There's a 50% chance you'll get it right if you just guess. Okay, now we've got the wires connected to the motor, and we've put a couple of screws in there. Like I said, I think they were 632. I don't think they were 440s, but in any case, you know, they sit in there really nice. The motor's on there. It doesn't really matter whether you put the motor on this way around or that way around. It's pretty symmetrical, so long as it fits in there nice and your axle shaft is aligned up where the axle shaft should go. Now it's going to be time to fit the gears onto the axle shaft. Now these can be a little bit of a tight fit. It may be necessary to just come in here and gently trim off a little bevel on one side, just the slightest of bevels onto the top right there. And just watch as I'm recording the video. I'll slice into my thumb and create a video of what not to do when you're cutting. Just a slight bevel on the outside edge, if you need it, can sometimes help. You might only have to put that on one edge. Be gentle. Remember, you're working with plastic gears here, so if it's not cutting, don't try and force it through. Otherwise, you're going to be demonstrating why it was a good idea to use screws. So I'm going to stop filming so I can use 2 hands and get in a more comfortable position to do that. But you're going to have to fit these gears on right here. Yeah, now that I think about it, actually the easiest way to carve that out and get a little chamfer is probably just on the inside of the gear right here, and just take a sharp little X-Acto knife and cut around in there. That's probably just the plastic expanded a little bit on the bottom layer while it was 3D printing. And once you get it started, you do have to be firm, not brutal, but firm with how hard you push down here. A little bit of rocking. And there we go. Hand strength, you don't have to take it to the arbor press or anything, but it should come in there and it should fit nice and flush on there. And you should check to make sure you haven't messed up your gears and that that spins around. Now, when you go to put the other gear on, and somewhere I've got it, right in here, okay? When you go to put the one on the other side, make sure they line up, right? You don't want to put this, if you've got that one on that way, the teeth need to align. It would be really silly to have this one on this way, because then you'd always be pulling and you'd never have this cam section right in here where there's no teeth, which is where you're going to be firing. Okay, now that you've got that together, you can assemble your various bits and pieces. So your shooter part's going to sit in the middle, this motor part's going to sit right up on top, and when you're holding it all together, you should be able to make things slide back and forth. Now that's going to be a little bit awkward until you get some screws in there to do the holding for you. So 440 screws seem to work pretty nice, and that should actually fit through there really nicely. You may need to use a screwdriver or a little bit of persuasion to get that to go through really nicely, and then it's going to slide through right in here. This is a little bit awkward to do with the camera on here, but whatever. It goes in. Get in there, you little bugger. It's going to come out like that. And so you're going to do that for each of your connections. Then down at the bottom, you do need a spacer to keep it off of the Boombot frame. And then you'll mount that with the spacers, once you've got all four of them in there, onto your Boombot frame. And then you'll need a 440 nut, of course, on the inside once it's all mounted to hold it all together. Now if you just want to test things right now, you can probably put one of those together just finger tight right now, and then hold that together right on there and slide that back and forth. And you can see the brilliant mechanism on how it works. It's a pretty standard mechanism, but brilliant nonetheless. We'll use an elastic band to pull things forward, and then as the motor spins, it engages with the rack, pulls everything all the way back. I think we've got one tooth too many on the top maybe, and then when you hit right there, the elastic can pull it forward, and then the motor keeps on spinning and pulls it around some more. So anyway, there you go. Drop your screws in right there, and you can actually take that and mount that onto your Boombot. Just remember the spacers. Okay, now I'll add some elastic bands on here, and I find number 32 elastic bands work pretty nicely, but there's sometimes just a little bit loose, so if they are, and I want to get a little bit more tension, I'll tie a knot in the middle of them. Now, to test that, you can just strip your wires right here and hook them up to a power supply. And this will also let you know which direction you want them to hook up. And now that's at 4.5 volts, which is a pretty good voltage to test at, and that's rather disappointing. But 4.5 volts is likely what you're going to see. It kind of stalls out at about less than an amp. So that's not so good. So we need to adjust the tension on there. We need to loosen it off a little bit, because what we want to see is something more like this. Okay, so that was running at 4.5 volts coming off of a power supply, keeping in mind that you are going to have some voltage drop coming off your power supply on your robot. And that means that these are just a little bit slack when they're sitting right there. So playing around with the tension of your elastics is going to be really important. And then I'll use one more elastic. I'll kind of wrap it around the inside right there to put some tension onto all of your discs and to keep everything from falling apart right in there. so that when you hook power up to it right now, and let's just give it that, all of a sudden things start to happen. And oh, hold on. Am I still recording here? Darn it. What happened there? Here we go. Your robot is dangerous now. Okay, so now it's time to mount your Canon onto your robot. And you've got 2 wires coming off there. With your testing with the power supply, you know which side of that is going to be positive. So before you do any crimping or anything like that, get that mounted onto your robot and find a nice way to run the wires down. Right in here, I think I only had 1 hole, so I had to route it on that side. My current design has 2 holes, so you can route it on whichever side you think is the most convenient and not likely to get caught in the way of any moving mechanisms on here. It's going to come down to the inside, and you're going to crimp a connector onto it, and that connector is going to allow you, now make sure you leave yourself enough space. You can see how I left this one a little bit short. This was my very first prototype, and I didn't really think that all the way through. I'd like that to be maybe just a little bit longer so that I could open the top entirely and leave that connected, but not so long that I've got loose floppy wires all over the inside. So that's going to come down on here, and your positive side wire is going to be coming through on the right hand side of the board, because what's going to happen is when it comes time to fire the Canon, it's going to be controlled by the TIP 120 transistor right here. We can't change the direction in software. This is always going to be hooked up to the motor power supply. It's going to go up to your motor, and then it's going to come back down here. And if the TIP 120 is turned on by your Arduino, then this can sync the current down here and your Canon will fire. And if the TIP 120 is not turned on, then it won't be able to sync that current and you won't be able to fire. So anyway, crimp connector right onto there. Seal up your top, and you've got, more like so, you've got your machine all ready to go and deliver some disc mayhem into the neighborhood.